Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach.
Okay, so Linux kernel internal. Now, if you know
Sorry,
Linux kernel,
sorry, I've got a question.
yes, tell me.
Um, I realized yesterday's session was very short, and I wasn't following, and I was expecting that.
This conference will now be recorded.
Okay, so today we are going to learn Linux kernel. Now, why this is very important? Because we are in the world of container, and you can understand the container well only and only when you can understand the kernel well. So Docker, if you want to learn, you have to understand kernel. If you want to learn Kubernetes, understand the Kubernetes internals, you have to understand the kernel. So many things is hidden in the kernel, Linux kernel itself. So what is kernel? What is Linux kernel? So basically kernel is nothing but a computer program. We all know that it's a computer program which is running at the its core, and we call it operating system. So I must ask you to define the boundary for the kernel and operating system. Okay, so when I say operating system, it has a kernel plus many other utilities for human beings. Okay, for example, you like some of you like a GUI, right? It's not a part of the kernel but still is there. Some of you like a notepad, calculator, or maybe some default browser or something. It's not a part of the kernel but still there in the operating system. So when I say kernel, basically is a kind of program which is running in your system at the core, and which is basically playing an interface between the human and hardware. How can you talk to hardware? Through kernel. How hardware can talk to you? Through kernel. Now, when I say hardware, that means what? CPU, RAM, storage, keyboard, mouse. These are the hardware, right? So input devices and output devices and processing devices, all these things. So yeah, kernel is a computer program. And now if you look at this here, this is the kind of things which is managed by the kernel. All the hardware, CPU, memory, disk, devices, and all managed by kernel. And on top of that, there are certain user levels applications are there, like Notepad and Firefox or whatever it is, GUI and all kind of things. So where kernel program runs, this is important. So basically, it is a portion of operating system. Of course, we know that. But you know what? When you start your laptop or VMs, the kernel programs is running in your memories basically. Yes, when you boot your laptop or VMs, yesterday we created a VM, right? So this is running in your memory. So that means kernel, it is a portion of the operating system code that it is always resident in the memory and facilitate interaction between hardware and software component. So that is something which we should understand. Now the next question is when the kernel program runs. So the kernel is one of the first program loaded on startup after the bootloader. That means when you start, let's put it in this way, when you say laptop switch on. So the moment you switch on the hardware, I mean motherboard has some very tiny software which is called bootloader, and the bootloader load your kernel and which runs in the RAM actually. So these are the types of kernel which you have: microkernels, monolithic kernel, hybrid kernel, nano kernel, exokernel. So we are using the monolithic kernel. By the way, do you know that Android is having which operating system? I mean, mobile Android, the one which you're using on a daily basis. Which operating system, which kernel they have it? Anyone have idea? Anyone? The Android?
It runs in Java.
It is a Linux kernel actually. Android is developed on top of Linux kernel. So we should take it Linux very seriously. Okay, so yeah, we more or less we discuss about the monolithic kernel. So what are the primary role of the kernel? So here primary of role of the kernel is task management. What is the meaning of task management? Guys, you look at this here. I showed you yesterday also. See, these are the tasks which is running in my laptop. I mean, I know it's plenty of it. I have not rebooted my system from last 5 days. These are the task is running. Who's managing this task? Kernel. Who's allocating the PIDs to each running task? Who's attaching the username to that particular process? Who's allocating the CPU and RAM to this each processes which you are running, services you are running? Who's doing all this work? Kernel. That's called task management. Second one, device input and output management. So you must be having keyboard, mouse, right? What else? Printer. What else? Monitor, right? So these all, how this interaction, input and output is being managed. So all this is managed by kernel. Okay. Any problems, any interrupt and events happening in the system handled by kernel. Timer management, kernel. Memory management, which process should get how much memory, kernel. And anything in between the process communication and sync is been kernel. So these are the primary role and function of the kernel. Okay, so again, yeah, full kernel control all hardware resources. In example, input, output, memory, cryptography, where device driver artifacts conflicts between the processes concerning such as resources, and optimize the utilization of common resources such as CPU, cache usage, file system managed by kernel, network sockets managed by kernel, memories managed by kernel, devices managed by kernels, and everything. Anyone have idea who's this person?
Linus Torvalds.
Yes, Linus Torvald. He's the father of Linux. He's the great guy. Not only is the father of Linux, but he is the father of Git also. And both of these tools you are going to learn actually. So yes, he's the person who invented Linux. The Linux kernel is a free and open source, monolithic, modular, multitasking, Unix-like operating system kernel. Okay, so it was originally authored in 1991 by Linus Torvalds, and some of the more details you have it, and so on. Now, where the Linux kernel has been deployed. So some of the things I said, like Android OS is having the Linux kernel, servers which we are using Linux kernel, personal computing also Linux kernel, some of the embedded device which you use for the IoT and machine learnings and robotics and all, they all are using Linux kernel. Frame supercomputers and all are running on Linux kernel. So let's start understanding about the bootloader. What is a bootloader? As discussed, this is the one of the first program which runs when you start your laptop or VM. A bootloader, also spelled as a bootloader or called as a boot manager or bootstrap loader, is a computer program that is responsible for booting a computer. Let me ask you one question. Have you ever run two operating system in one physical laptop or desktop? Have you tried? I have tried in my college time, because we were having the base Windows and I want to learn, I want to load, I want to install the Linux also. So have you tried such certain thing, kind of things? Not, I'm not talking about the VM.
No, no. We have tried it during our college times. Before the Windows boot up starts, we could, partition into Linux during the
Bootloader,
college.
yes, right. That was a bootloader configuration you were doing actually. So we were modifying, hey, bootloader Windows or bootloader Linux at that time. So yeah, that is the first program which runs bootloader. We can tell bootloader, hey, bootloader, you can run this Linux, you can run that Windows. So many things can be done here also. So yeah, this is the one program which runs. So when a computer is turned off, is software including operating system, application code, and data remain stored on non-volatile memory. When the computer is powered on, that's important. It typically does not have an operating system or its loader in random access memory. Okay, so that you must remember that the bootloader is the one of the first program which when you powered on, then it get loaded, and after that it load the kernel and so on. So again, multiple terminologies are there. Right now you don't need to get into that so much of complexity, but I'm just helping you to understand how it works. So look at this, the flow: power on, ROM code, booting devices, bootloader, kernel, and then you get a platform. So overall, this is the things. So power on, load bootloader in ROM, load kernel in RAM. There is a difference between ROM versus RAM. Where is the ROM is located? In your motherboard. Okay, so when you powered on, the bootloader get loaded in the ROM, then run your program, and after that it call kernel, and then in RAM, then kernel code in RAM. Remember that. Okay, so this is the image which I will ignore it for time being, and this I would like to stress here. So now, guys, if you look at this, especially look at the left side, there are three space we have. Okay, if you look at this, there is one called bootloader space, second one called kernel space, and third one we call it a user space. You have to remember that all the time. By the way, if I look at the user space, and here there is one thing which is called root file system and init process. Init process, okay, but what is a root file system? Anyone have idea what is a root file system?
The first file system that it creates under root bin.
Right.
Um,
Yeah. So you should not
there is a
forget,
structure.
because right, yeah, you should not forget this is the root file system. I'm going to have use happily this keywords what I'm teaching you right now in the line container topics, Docker topics. Okay, so this is the one. So here, mind it, this is not a part of the kernel. It's not a part of the kernel. You can look at this image here. Is it a part of kernel? No, it is not a part of the kernel. It is a part of the user programs. It's not of the part of the kernel. So that means whatever you see under the root is not a part of the kernel at all. It's coming on top of the kernel. And kernel is running all the time in the RAM. Okay, so if you see that bootloader code which get loaded, and then here there is a three stage sock ROM bootloader. No need to remember, just to understand. First stage bootloader and second stage bootloader. Now in short, you need to understand the moment you turn on your computer, bootloaders get loaded, and the bootloaders call the kernel. Look at this here. Kernel, Linux kernel. Okay, and after that kernel initiate the process of root file system. So that you must remember. Now one thing I would like to tell you, kernel run in the kernel space, left side, the one which you have, kernel space. If someone will ask you, hey, where is the kernel is running, this is one of the interview questions, you should say kernel space. What is a kernel space? I'll come back to you in some few minutes, but just remember that. And where the root file system is running, user space. Where the notepad is running, user space. Where the browser is running, user space. Where is your editor is running, user space. So understand this. So now the question is, what is the difference between the kernel space and user space? So here what is happening, the system has been designed in a way like, see, you get a memory and everything runs in the on memory. Understand that. So all the computer memories, okay, virtual memory has been segregated into two parts. That is one user space part and one is kernel space part. That means whatever the memories you have, it divided into two parts, user space, kernel space. Now why we have this division? A computer OS usually segregate virtual memory into user space and kernel space. But why do we have this space? So understand that if you run all the program in one space, let's say we do not have a two space, only one space. So one programs, if it is a can create a trouble for other programs. Yes, create a trouble for another program. So let's say I'll put it in this way. Here there is one Chrome can kill the GoToMeeting, and GoToMeeting can kill to the Chrome. Why? Because you may write some bad code and you run in the system, and in that case, what will happen? That these programs, bad code can kill to each other and disturb the stability of the system. So ultimately, what do you want? You want the stable system, up and running system. About it, it's a protected. That means any program which you are running, you cannot interrupt the kernel. Yes. So if you look at this here, the kernel performs tasks such as running a processes, managing a hardware devices such as hard disk, and handling interrupt in this protected area called kernel space. In contrast, application programs such as browser, word processor, audio, videos, players, and is running in the user space. Why? Because whatever the program you are running, it should not destabilize the operating system kernel. System should not get crashed. Why? So that's the reason we have the kernel is running in the kernel space, which is protected, and then users are running in the user space. Okay, so please remember this. So why the kernel have user space and kernel space? Kernel space, the primarily the separation serves to provide memory protection and hardware protection from what? Malicious and irrelevant software behavior. Okay, so this is the region. So now we are clear that like after the bootloader space we have a kernel space and user space. Kernel space we run the kernel, and then in RAM, and user space also run the programming, I mean user program is run in the user space. Are you clear so far?
Yeah.
Okay, so in this
Yeah.
image, if you look at it a little bit carefully, guys, if you see that there is one supervisor which is accessible by kernel. That means, let me tell you here in this way, any users who's running the program in user space, for example, you are running browser. Okay, so I must tell you here, kernel space has access to the all the program to the user space, and this is called supervisory. Okay, so kernel runs in a supervisor mode and has access to the user section as well. Why? What is the reason? Because remember that who's managing the memory? Not user space. Who's managing the memory? Kernel. And user space, to run the user program, you need a memory. You see that here? You need a memory, right? These all are some, forget about the system. Look at the Rajesh one. These all required memories, right? So who's
Yeah.
providing this memory? Kernel. So kernel also control, supervise the user program also. But user program cannot supervise the kernel program. Okay, so application run in a user mode has a limited privilege. Each application has its own virtual memory map. So please remember that supervisory mode. Now, this is the interview question, and I must tell you here, uh, 10 years before, when I had attended some of the interviews, and at that time, minimum I think 10 to 12 years before, I guess, this question was asked one of the fan companies, and I could not answer this, and because of that, I had a I regretted a lot at that time. So what is this? So the question they ask, hey, you are running some programs in the user space, so how the process which is running in the user space get the resources allocated? When I say resources, means RAM, disk, and all. And the answer is, what is the answer? You tell me, what is the answer?
Kernel allocates it, right? Because that's
No,
responsible for.
no. Question is, processes is running in the user space, but how these processes get the resources allocated from the kernel? And the answer is,
System
resources means
calls.
RAM. Answer is,
They use system calls to get the request, and the kernel
right,
allocates.
system call. You should say syscall or system call. So system call is a kind of program interface between the program which is running in the user space and kernel space. I must remind you, who allocate the memory? Kernel space. Who needs the memory? User space, because you run the application. So now user space, any processes you run, user space beg the kernel, hey kernel, give me the RAM. Hey kernel, I want to read this file. Hey kernel, I want to write this file. Hey kernel, I want to send this instruction. Hey kernel, I want to read this instruction from the keyboard or mouse. How it is happening? Syscall. So this is the interface. Now syscall is like a one interface, in that you have a multiple methods. These all are the code actually redundancy. So multiple method. For example, when you run the cat etc host, you might have run it to see the content of the file. So what happened? Syscall happen, one open method is being used, and they make a call to the hardware with the help of kernel space. You run a bash, certain commands. What happens? Create a get a PID. Who's giving it? Kernel space. You need a network IP address. Who give it? Kernel space. You need a CPU. You need a RAM. Who give it to you? Kernel space. Through what? Syscall. Syscall has a multiple method. You don't need to remember though. But this is one of the ideas for this. So if anyone is asking, hey, the process running the user space required the resources of the system, how can we get it? So you can say all the processes, all the resource, I mean all the application running in the user space do the syscall to the kernel to get the resources available. So that is important. Okay, so now kernel space and user space, this is the, I think you are understanding. All of you are clear? All of you are clear?
Yeah.
Yes.
Okay, so now this is little complicated image. I will ignore it because this all has all the method code, function of the C program, which is part of the C kernel. I mean, this kernel space and user space. You don't need to know for time being until you are a kernel programmer and so on. Okay, so this is the image. You might have seen it hundreds of times, right? When we started our colleges and all, hardware on top of kernel, on top of shell, and top of that user program. So shell, what is a shell here? Shell is basically is a way, so we connect to the kernel, we send some instruction. Okay, so this is the some of the architecture, so now again repeating this one, the program's kernel is running the kernel space, and the user program is running the user space, and there's a system call interface. Look at this in between. System call interface, which basically serving all these things. In a system call interface, we have hundreds of functions, though you don't need to remember, but it is like that. So yeah, this is the hardware on top of syscall to user interface and user program. I think we discussed and so on. Okay, so yeah, so this is the something services provided by the system call, including the process creation and management, memory management. If you want to access file, syscall, directory, syscall, file system management, syscall, input output, syscall, protection, syscall, networking, syscall, for everything there's a syscall. Okay, so this is the different types of syscall. I'll just ignore this image. Yeah, so
Rajesh,
types of syscall.
I have a question. How
Yeah.
there is a segregation made on user space and kernel space? Like how kernel space make sure that none of the user space applications does not disrupt anything within the kernel space.
Okay, so the area is like this. Any program which is running in the user space is handled, again supervised by the kernel space. So if the kernel space is seeing that there is a certain irritant program which is creating bringing the instability in the system, so they stop giving that CPU and RAM, and automatically this is called zombie process. So something like that, they have inbuilt coding to manage such kind of things. So idea is like we should not destabilize the operating system. That means runtime environment. Okay, so some of the things I'm ignoring because you don't need to know. It's become a very complicated. So this is something which you don't want to understand right now. These are the list of functions for syscall and so on.
Raj, I have one question. You said kernel interfaces are created in the C language, right?
Yes. Yeah.
So C language doesn't support interface. It's only Java supports interface.
Uh, okay, so I don't know which interfaces you're talking about. This, when we say interface, is a generic word to connecting between the two world. Okay, so here the world is this kernel space and this user space. So I don't know when you are talking about the programmatically interface. That's not I'm talking about. Remember that Java required JRE to run. JRE can run on top of the kernel and operating system only, right?
Right. Okay. Okay.
So so yeah, so these are the main operations of this, and after this you need to understand the process and thread. Okay, so what is a process and thread? So guys, let me show you in the windows, it will be easier and faster. These all are processes. Okay, and yesterday I have also talked about it. These all are processes, and these are the PID. So each processes whichever is running attached with one PID. Did you notice like this all start with 0? That means everything start with 0. That means everything start in the whole world with nothing. Right? Have you seen that? 0 in Linux also. Let me log into one of the Linux box. Do we have a Linux? Yep. Here if you see ps-ef, this is the Linux, and you see here everything you have a starting with a 0. You see the first process is called 1, which is running your initialization of your root file system, which is happening here, and then 0. Okay, so this all started from the 0, nothing. In Windows also I just showed you 0, but here the first process 4. So what is happening? First and second, fourth you can say, call it a first process. First process which is running your NT kernel and system. Here in Linux, the PID1 is running your kernel. So if you see here, then what has happened to 1 and 2 and 3? So basically maybe before kernel they were learning some short processes which they killed it, so it's become a 4. After that 5 got killed, 6 got killed, 7 got killed, and all continued till 164. Then you see that this is a sequence. So now if I start one more browser, it will become one more actually. So like this, see here in Linux also. So here all these are processes. So nothing great about it. You are comfortable, I know that, with the processes. So now what is a thread? So this is a very important question, and interviewer will ask you, what is the difference between process and thread? Why do we need a thread? Okay, if you're coming from the programming background, then threading concept must be aware of it. So what is a thread? So here you see, here one process can have a multiple thread as per the image. So one process can have a multiple thread. Now if you see that, so here CPU created processes. CPU empowering the process. Each process get a CPU, and CPU a process share that CPU. Please understand this. Process is empowered with the CPU, and here processes share the CPU in a multiple thread. Look at this image. So what exactly I'm trying to say here? So let's understand this way. A process is a computer program under execution. Yes, if it is not execution. See why we have a difference between 164 and 172, because in between there were processes running which got stopped, so that's not a process anymore. So these all are under execution, running state. It's running state, so that's the reason we have a process. So process is a computer program under execution. Linux running many processes at any given time. We can monitor them on the terminal, which I was showing you, ps-ef and all kind of things, and the command and the system monitor UI as well. So this is the process. Now every process we get, how do we identify which process? So every process we get a PID. Now through the PID map, I must tell you, when I say PID and PID map, there are differences. Let me draw a picture quickly. So when I say PID map, okay, when I say PID map, that means what happens? The first thing, which is a one map, you have PID map. Uh, Start with 0 always. Please remember that PID map start with the 0. Okay, and this 0, we have a first process which is loading your kernel, and after that you logged in, Rajesh logged in, Ramu logged in, and let's say Shamu logged in. So 3 people logged in. I'm just giving an example. Now Rajesh is running Apache, so 5. This guy is running MySQL, 6. This guy is running cat, 7. So this is the whole map is getting created. Now here you see in a here you see, where is that? I lost it. So here you see 1 2 3 like that, but this is the map kind of things. Are you understanding what I'm trying to say?
Yes, Raj.
So how many maps you get it? One map. This is one map. One map is equal to 0. And this is the PID. This is the PID. This is the PID. So that means every process which we run gets one PID. And that is how through the PID we allocate the CPU and RAM. Okay, so since many processes are running at any given time in Linux, they have to share the CPU. The process of switching between the two executing processes on the CPU is called process context switching. I don't know how many of you know. I just want you to focus on my screen and tell me what you are observing. I want you to observe this because it's very important concept, okay? I want you to observe this part. This part. Okay, in Windows I'm showing you because it'll be much easy to understand. Okay, this part. See guys, how many processes I'm running? I mean, more than 300 processes, I guess. But are you noticing something? Tell me, what is your what is your observation here?
A couple of them, it's the CPU is 00.
Yeah. So guys, what is happening? Let me tell you in a simple way. What happens? See, there is a two things which we have, memory and CPU. So mind it, every running process, I repeat, every running process will have memory allocations. So it is running. Yeah, process running as long as you have a memory. But it's not doing any operations until CPU is allocated. Sorry, getting my points. So every running process has a memory. Look at this very carefully in this image. Is no as such you have this is a you can say interrupt, not required memory. So here all process is getting memory, so it is running. But if you look at this part, this most of the process is not getting CPU. So what is happening here? What is happening here? So let's understand this part. Let's read one more time here. Since many processes are running at any given time in Linux, they have to share the CPU. That means every process which is running, they have to share the same CPU. The process of switching between the two executing process on the CPU is called process context switching. That means what we are trying to say, system is running, please hear me out, system is running all the processes but cannot be allocate the CPU to all the processes, only at a time one. So here CPU has been allocated to this one, after that second it will be allocated to this one, after that it will allocate to this one, like this. So CPU is getting allocated to the one process at a time, at a time. Memory is being allocated, no problem, but CPU is getting allocated to the processes at a time. So let's say why I'm getting this go to meeting, because this I'm running, I'm showing you my screen, but CPU is getting allocated here. But you know what, this if you understand this one at a time. So what happens, I'll tell you very simple way. Let's put it up in this. So here there's one application running DWM and go to meeting. Okay, so here what is happening, CPU got allocated here, after that immediately they'll get allocated here, again it will allocate here, if you run some program it will allocate here, again get back to here. So this is the always CPU is always switching the allocation. And let me tell you here, this is happening so fast you cannot imagine. Right now you are seeing very slow, but it is happening so fast you cannot imagine. You will not realize, okay, I'm having some issues with the performance. So but what is happening, I'll tell you. While switching the CPU, let's say it's CPU is switching from here to here. what happens? This, whatever the state of this program, has to be stored somewhere, right? I'm chatting to you, I'm talking to you, my audio is being delivered, my screen is being delivered. It has to be stored somewhere in the memory, stored to delivery. So what happens? This is consuming, this get delay little bit in a very nanoseconds actually. It's get delay. But the process of switching the CPU from one process to another, this process is called, what do you call it?
Context switching.
Process context switching. Now you saw that, right? I don't know how many of you have noticed earlier. Where is that? Here it is. Look at this in CPU. We think it's allocated to few. No, actually it's so fast we are not able to realize that actually. So now the question was, okay, so process we understand, and we understand the allocation of the CPU to the process. It always switches based on the program which you are running. See, I'm showing you what PowerPoint, right? Suddenly it got switches. CPU got allocated. Now after that, again I close this slide. Again you got switched to the CPU to here. So whatever you are running at that time, experiencing it, CPU get allocated to that process actually. So who's doing all these things? Memory, I mean, kernel is doing all these things. But the question was, okay, what is thread then? What is thread then?
Collection of
So please,
process.
uh-huh.
It's a thread is a collection of process. Sorry,
Thread
a
is one of the
process is a collection of threads.
yeah.
Thread is used to do certain tasks.
Yes. So here let's understand the problem with this process context switching. Okay, from the one process to another process, CPU switches. Okay, so when switches happening, see, understand that process context switching is expensive. Why? Because the moment the kernel has to save old register, means let's say you are running Firefox and I'm running notepad. So first time I'm accessing the Firefox, so CPU needed, so switches here. Again, next time I have opened the notepad, the CPU needed here also. So this all switching, now what happens? Firefox, whatever browsing you were doing, it has to save. Notepad, whatever I have written, it has to save the state of that things. So what I am trying to say here, kernel has to save old register, that means whatever the data at the data of the process state, and load current register, that means notepad versus Firefox, putting in a simple way. Also memory maps and other resources. But you know what? This is expensive. What is expensive? That means this, because of this process CPU context switching, process context switching, this get delay. Your system is little bit slow. I mean, you don't realize it, but if you look at the scientific terminologies, it becomes slow. Okay, so what to do? How can you make it the system very speed? So if you're coming from the background, let's say some of you are from Java, I guess, what do you do? Thread programming, correct? So this same thing is kernel is also doing. Let me show you here. Kernel is also doing the same thing. So what is the thread? Thread is a lightweight process. Okay, that means process is a process, thread is also process, lightweight. But in what way? So what happens? A process can do more than one unit of work, one unit of work concurrently by creating one or more thread. These threads being lightweight can spawn quickly. That means a process can spawn the thread multiple very quickly. Okay, so what is the benefit of this? What is the benefit of this? So let me talk about it. A benefit is, where is that? Somewhere I have written actually. Huh. So read this. uh, I think I'm not able to find it. Let me explain it to you. Okay, so it will be there in the slide, but somewhere. Okay, so what is happening? This is the process. Okay, understand that. And then process has spawned multiple different thread. This is also lightweight process, by the way. Now I'll put it in this way. This is the process of what? Chrome, and you are running the one window. I mean one tab, second tab, third tab, fourth tab. That means fourth thread. Okay. Now what is happening? This once the CPU is this one allocated to this process. Now this process share the CPU with multiple thread. See here, multiple thread. So what is happening? This all process is running at a concurrently, right? Don't you think so? Because I told you very clearly, when you give the CPU to the process, then that process runs, and it happens so fast beyond your imagination. But what is happening? Earlier I was able to run only one process at a time, but here I am able to run multiple process, which is lightweight process at a time. Because what is happening? Process versus thread. Process receive the CPU, share the CPU with all the threads. So what is the advantage? So advantage is CPU context switching, the time which is being saved here. Are you understanding what I am trying to say?
Yes.
Yeah.
So this is something which is called a thread. Why we use the threading programming? We do all this thing in programming also. Okay, so you can run multiple processes concurrently by doing that one. Okay, so now if you see that a thread is a lightweight process can do more than one unit of one process can do more than one unit of work concurrently by creating one or more threads. These threads being lightweight can spawn quickly. Let's see an example. So here you can see that let me show you in the Windows. It will be Linux. It will be easier. Here it is. See here. So if you see the table, see here, PID, parent PID, LWP, NLWP. So here N means number of thread. So if you see that this process number of thread 1 till okay here. Now if you see that this process has a number of 6 thread. See here, and these all 6 thread 1, 2, 3, 4, 5, 6. So you see that? So here is 6 thread. So the process ID 187 has a 6 thread. Are you able to see that? So that means whenever the CPU get allocated to 187, this 187 share the CPU with all this. So you can do hell lot of things in a very fast manner. Are you able to understand this?
Yeah.
Yes, Raj, I have one question. Okay, in
Yeah.
Windows, what will happen if you open a browser? For example, Chrome will one tab will have 8 threads. Okay, and Microsoft Edge will have 2 threads per tab. Okay,
Mhm.
similarly in Linux, what is the maximum number of threads we can go for a process?
To be honest, I have no information on this. Probably we should Google it for that. But what is the limitation of the thread for the each processes? I don't know, to be honest. So let me just find out. Linux maximum. I think it should be
Threads per
unlimited, I guess.
process.
Maximum number of thread for each process.
It should depend on your RAM.
So my God, here the output it indicates that the kernel can execute maximum. This is the one. It's a huge number actually. It's
Okay.
yeah. But this is I think this is for the supercomputer. I mean we cannot run this many of thread and processes in our laptop or VMs because too much actually. For supercomputer maybe or data centers.
Right, right. Okay,
Maybe it
okay,
should
Raj.
depend on the RAM size.
Yeah.
I ran
Okay. So
1000 threads once, but that doesn't affect anything in Linux. So, okay, now got it.
I think I need to
63,000
remove this
threads.
63,774.
Ah, yeah,
Yeah.
thank you.
So this is the one. So now you understand the thread concept. This all this whatever I showed you the demo is the explanation is there. So I'll just ignore it. So yes, we understand that single thread process. Any thread created within a process share the same memory and resources of this process is called single thread. Multi-thread we discuss about it. So same thing we have to read a little bit more. Left side you have a single threaded share all the registered memories, data files, and all this thing. Multi-threaded also share their own resources. Process internal, so this is not required. And yeah, So I think this one is a good slide for your interview perspective. If someone will say, hey, what is the difference between process and thread? So process is a heavyweight. That means why heavyweight? Because when you get a CPU, and the CPU get deallocated to different process. Before that, it saved the registrar and other details. So it is expensive. It's heavyweight, but thread is lightweight. It share the CPU within the that process. A process has its own memory. Mind it, memory. A thread share the memory with the parent process and other thread within the process. That's important. So here this is the line I was looking for earlier. Inter process communication is slower due to isolated memory. Mind it. So each process, if you switch the context of CPU, it is slower. But inter-thread communication is faster due to the shared memory. Because all the memory is shared within the same process. Uh, Context switching between the processes is expensive due to saving old and loading new memory, new process memory and stack info. Here, context switching between threads is less expensive due to shared memory. So that is the reason what is happening. Many programmers are creating a code to create a process, and but they have a multiple thread. So that is one of the reasons. So speed of the software, performance of the software can be enhanced. Okay, so I think we all are clear on these terms of process and thread, all of you. So next one is scheduling and preemption. So let me put it in a very simple way. uh, Here, so Linux kernel control the way the task or processes are managed on the system. Okay, the task scheduler, this is the part of the kernel. Okay, task scheduler, Linux scheduler is a part of the kernel. Sometime you call it a process scheduler also. So you can call it process scheduler, task scheduler, Linux scheduler, whatever you want to call it. Okay, is the part of the kernel that decide which task to run in next. This is a very important. See here, look at this. Do you have a control on, look at this windows, huh? Do you have a control on which task has to run? Can you dictate this? See your CPU allocation. Look at this very carefully. See that? Oh my God, it's going down fast. Why? Huh. So see here, CPU allocations. Do you know? Can you tell which process to run fast? That's not your job actually. You cannot. I mean, theoretically through coding you can do that. That's a different thing. But yeah, that's not job. So who's doing all this work in the kernel? Linux scheduler, aka process scheduler, aka Linux kernel control. I mean, manage. I mean, sorry. What do you say? Task scheduler. Okay, so this is one of the component of the Linux kernel which decide which program to run first and which program to run fast. So here, let's understand this. Let's complete this. It is responsible for best using system resources to guarantee that multiple tasks are being executed simultaneously. This makes and it is a core component of any multitasking operating system. Okay, so that's one of the component which you should run. Now there is one more which is we have preemption. This is also only one line. I want you to read this. Okay, so what is a preemption? So here understand that theory behind the task scheduling is very simple. That is taken by the task scheduler. If they are runnable process in a system, at least one process must always be running. This is important. See here, if there are runnable process in the system, at least one process must be always running. And do you know which process should be always running? You have seen this just now. Tell
It,
me.
it,
This one.
Kernel.
Correct now?
In
This one.
in
idle,
which?
idle.
Yeah. Correct. So the first process should be always running. In Linux also, PID1 is always running. Okay. So here, therefore, some process need to be stopped temporarily or suspended so that others can be running again. So who's doing? The scheduler decide what process in the queue will run next. That's the last topic. As already mentioned, Linux, like all other Unix variant, is a multitasking operating system. That means several tasks can be running at the same time. Linux provide a so-called option which is called preemptive multitasking, where the scheduler decide when a process is suspended. This forced suspension is called preemption. This process is called preemption. That means the kernel will decide which process to suspend, which process to run next, and several tasks can run at the same time. So all this process is called preemption. Okay, all Unix flavor has been providing the preemptive multitasking since the beginning. Okay, so this is the last thing which I would like to you to understand, and after that not required, and so on. Okay, so let's do the little bit of review. First thing, did you understand the what is kernel, types of kernel, function of kernel, how kernel works, different spaces, user space, kernel space, bootloader space, how this processes between the user space and kernel space interact, system call? Do you understand the process? What is a process? Do you understand what is a thread? Do you understand the task scheduler? Do you understand the context switching? All these things? All of you? Do you understand this?
Yes.
Yeah.
Yes.
Do you understand the tree map? I mean, sorry, PID map? All of you?
Yes.
So, yeah.
Yes.
Let me ask you one question. How many PID map each operating system you see?
One.
One. Wonderful. Yes. How by default? Okay. Let me ask you. How many users you can create in the operating system?
Many. I'm not sure. Many you
Yes.
can.
Yes. Yeah. I'm going to ask you this question in Docker session also, by the way. Sleep. That's the reason I'm reminding. Okay. How many root file system you have seen so far in the operating system?
Unknown
One.
root.
How many?
One.
One single.
One.
But guys, soon we'll be seeing multiple. Yes, soon we'll be seeing multiple. How? We'll discuss Docker and then I'll remind you. In the regular basis, one root file system you see, but that means one C drive in simple way, one bit tree you see, one network you see, multiple users you see that you can create and or running. But in a Docker, whole these are different context in the world of context. So please remind yourself. This got it, all of you?
Have any issues with our channel membership, you can drop an email to us at contact@debugschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.